Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because this hour is your hour. Find out about all the incredible breakthroughs being done as now for the first time in world history, we're teasing apart the thinking process. You realize the Pentagon understands the importance of this. The Pentagon has dumped over $150 million to hook up the human brain to an exoskeleton to give the gift of mobility to our wounded warriors from Iraq and Afghanistan who have injured spinal cord injuries. Think about this. Think about this because Christopher Reeve, the handsome actor who played Superman in the Superman movies, well, he suffered this horrendous fracture of the spinal cord leading to paralysis, and he died. He died hoping that one day we would be able to bypass the spinal cord, the injured spinal cord, to hook the brain directly up to mechanical arms, legs. That dream is now here with us today. Find out more about mental illness, about dreams, about why we think the way we do by getting a copy of my latest book, The Future of the Mind. Go to my website, mkaku.org, mkaku.org, or go to my Facebook site, Michio Kaku. And we have almost 3 million fans on Facebook. And go to my Twitter site. We have about 300,000 people on Twitter. Okay, so once again, the lines are open. 866-323-2129 is the number to call. So let's have the first listener phone call.
Hi, this is Robert calling out of German, Pennsylvania. And WYOK is the news station, is the frequency I'm watching, 103. My question is, actually I got two questions. My first question is, how hot is the sun? And my second question is, how far is the moon from Earth, from the ground up? And if we had a blackout of the sun, can people still survive without the sun? And that's my last question. Thank you for taking the call.
Well, you ask questions that have haunted scientists for centuries, wondering about the simple dynamics of the sun and the moon. And fortunately, using modern science and modern-day space technology, we can answer all these questions. First of all, in the 1800s, scientists asked a simple question: how hot is an object? And they began to realize, using the science of pottery and ceramics, that hotter objects, they can become so hot they emit light. So color corresponds to temperature. Now, we know that instinctively when we say something is red hot. And we instinctively know that white hot is hotter than red hot. And so we already have intuition that temperature is associated with color. And that's absolutely right. In fact, we physicists have a mathematical formula that tells you the frequency of a color and the temperature of the object. So think of the colors of the rainbow, or Roy G. Biv. Roy G. Biv stands for red, orange, yellow, blue, indigo, violet. Red being the coolest of the colors, corresponding to a few thousand degrees in terms of temperature. Blue being one of the hottest of the temperatures, corresponding to maybe, let's say, up to 10,000 degrees. And so by looking at the sun, we know the sun is yellow, so it is yellow hot. Yellow is between red and blue. It's in the middle. So we know, therefore, that the surface of the sun is, well, rather cool. It is yellow hot. So believe it or not, there are objects on the Earth that are hotter than the surface of the sun. Now, the interior of the sun, we actually know the temperature because we have computer models of the sun itself. The interior of the sun can be tens of millions of degrees in temperature, but the surface of the sun is yellow hot, meaning that it's only in the thousands of degrees, and that is the temperature of the surface of the sun. By the way, we can also calculate the temperature of outer space. Outer space has a temperature, it's 3 degrees above absolute zero. that corresponds to the microwave range, and that corresponds to the leftover radiation from the Big Bang itself. So believe it or not only do we know the temperature of the sun, we also know the temperature of the universe. And the temperature of the universe is 3 degrees above absolute zero, because that is the temperature of the original explosion, now cooled down, which created the universe, the Big Bang. And then the moon, we know exactly how far the moon is from the Earth to within a few inches by putting mirrors on the surface of the moon and shooting laser beams off the surface. So light takes about a second to reach the moon, and to come back takes about 2 seconds or so. But we know exactly how long it takes, and therefore we know exactly the distance from the Earth to the moon within a few inches. And that is 250,000 miles. And so, well, when I was a kid, I used to shine a flashlight on the moon, and I used to ask myself a simple question. How long would it take for the light to reach the moon? And how much of the flashlight would reach the moon? Well, now I'm a physicist, and I can calculate all these things, that the flashlight, the light, would hit the moon in about a second. And yes, a tiny fraction of the flashlight's light will actually impact on the moon, to the order of a few % of the original amount of flashlight. And then you ask another question, what happens if there's a blackout? First of all, if the sun were to be blacked out, the initial impact of it would be, well, the Earth would be hurled out of its orbit, but without starlight, without the sun's starlight hitting the Earth, temperatures would eventually plunge, and we would go into a nuclear winter scenario, and eventually all life on Earth would be extinguished, because we depend upon the sun to heat the Earth. And if there was a solar blackout, that would be pretty much the end of life on the Earth. Okay, well, moving right along, let's take the next listener phone call.
Hi, Dr. Kaku. My name is Nicholas. I'm calling from Ormond Beach, Florida. The call sign for the radio is 93.5 FM. My question is, I was at the pool today, and not only will this mom not let her kids have cell phones, which I think is great, but they both have not laptops, but notepads. But when they use their notepad, she insists on putting tinfoil on their laps because she's afraid of cancer, testicular, I guess, but cancer from cell phones and the notepads. So I was wondering what your opinion or what your thought is on that. Thank you, and I love your show. I was a taxi driver for years, and boy, you helped my night go by. So thank you very much, Doctor. Bye-bye.
Okay, well, you ask an interesting question, because just last month there was yet another study on the link between cancer, perhaps, and cell phones. So let me tell you right off the bat that the relationship is extremely weak, that you have to, hit animals with an enormous amount of microwave radiation, much more than you get from an ordinary cell phone or electrical appliances, in order to get the slightest increase in, for example, lesions. Now, the grandmother of all such studies was done in Stockholm, Sweden, at the Karolinska Institute. They looked not at cell phones, but power lines from huge overhead cables. And there are houses that are fairly close to these cables, so they could calculate the distance to the cables and what was the increase in cancer. And yes, they found a tiny correlation. Our correlation was barely measurable, but the farther you were away from these high-voltage power lines, the lower the level of cancerous lesions that the people got. Their conclusion was that cell phones release only a tiny fraction of the electromagnetic radiation as these high-powered cables, and therefore, in the short term, there's nothing to worry about, except it should be monitored, and new studies should be done all the time. First of all, there are two kinds of radiation, ionizing radiation and non-ionizing radiation. Ionizing radiation is like X-rays, very powerful. They will rip atoms apart, creating what are called ions, which are stripped down atoms. And these ions can create havoc inside the body. In fact, it can cause cancer. By hitting normal tissue with X-rays, you can show a definite increase in the amount of cancer. For example, CAT scans. CAT scans, in order to get these gorgeous three-dimensional pictures of the inside of your body, have to hit you with sizable amounts of radiation. And so I would say that if you have a choice, go for an MRI scan rather than a CAT scan. CAT scans hit you with a lot of X-rays, but MRI scans are non-ionizing. They are so weak they do not rip atoms apart. Now, here's the controversy. Even though non-ionizing radiation like microwaves and radio are too weak to rip apart atoms, is there some kind of unforeseen effect, an effect that we scientists don't quite understand, that could be causing cancer caused by non-ionizing radiation? And the answer to that is, quite frankly, we don't know. We don't know what the mechanism is, but the textbook says there should be almost no correlation. But we see a slight correlation between cancer and cell phones. So word to the wise, for the most part, don't worry about it. It is so small, it's hardly measurable, but more studies should be done. And after the break, I'll tell you how to measure the amount of radiation inside your house.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science. And in this hour, we're throwing the lines open, so this hour is your hour. Once again, you can be part of the fun. You can give us a call by calling 866-323-2129. All we ask of you is that you leave your name, the call letters of the radio station you're listening to, and the city calling from, and perhaps you can have your thoughts heard on over 100 radio stations that carry Science Fantastic. Well, before the break, we had a question about a mother who uses protective measures to protect her kids against potential harmful electromagnetic radiation coming from laptops and tablets and what have you. So the short answer is, calm down. The amount of radiation you get is so small, it is barely measurable, but we are scientists, and so we try to measure what little effect there is, and there does seem to be a slight correlation. Well, first of all, putting tin foil on your laptop does almost nothing. For example, some people think that you can build a cop buster by putting tin foil around your hubcaps. Well, I don't think that's going to work at all. I don't think any cop has ever been stopped giving you a ticket because of tin foil inside your hubcaps. If anything, it may make your car even more visible to radar by putting extra metal inside your hubcaps. And remember, the laptop computers and tablets do not emit that much radiation unless, of course, they're communicating with the Internet. Now, if you are concerned, why not go to a scientific supply company and buy a magnetometer or a Gauss meter? They only cost a little over $100. There are several scientific supply companies on the Internet, and you can order it right off the web. And you can measure the radiation down to several hundred milligauss. It turns out, for example, that when I bought my Gauss meter, I analyzed my house, and I was rather surprised to find that the largest source of radiation came, first of all, from hair dryers and the cable box. Right on top of the cable box, the radiation levels were about 100 milligauss, and same thing with your hair dryer. But again, you don't necessarily keep your hair dryer on for hours at a time. And it turns out that if you scan your wall, you can actually see where the hidden cables of electricity is carried. You can actually detect that by pushing this magnetometer across a blank wall. But in terms of cell phones, it was almost unmeasurable. in terms of the radiation given off. And so in other words, the word to the wise is, I wouldn't worry about it. However, we scientists are continually trying to measure what little effect there is to be on the safe side. It's always good to be prudent. And disregard some of the old wives' tales that you get on the Internet. It's an old wives' tale, for example, that some guy who used his cell phone a lot got a brain tumor that was the size and shape of his cell phone. And so it was a cancerous tumor, the shape of the cell phone inside his brain. Well, that was obviously an old wives' tale. But, hey, these stories do get circulated around. So once again, we scientists are monitoring the problem. But so far, we don't find much cause for concern. Okay, well, let's move on to the next listener phone call.
Yes, doctor. Is it possible that black holes are negatively charged on the outside, positively charged on the inside? That's why they will absorb a galaxy but still bounce off each other? Could they have a polarity problem? Thank you.
Well, you're absolutely right that black holes can be charged. In fact, it's called the Nordstrom-Reisner solution of Einstein's equations. Einstein's equations themselves were formulated in 1915. A year later, Professor Schwarzschild, actually working while he was in the military, working on the Russian front, he was able to solve the equations of Einstein and got the first black hole equations. But then they were modified yet again by Nordstrom and Reisner to have electromagnetic radiation, and bingo, they found yet another exact solution of Einstein's equation called the Nordstrom-Reisner solution, which describes charged black holes. But you ask a slightly different question. Can they be charged positive or negative depending upon what side of the event horizon they are on? And the answer to that is probably no. The bizarre properties of black holes are not due to the electromagnetic force. The electromagnetic force is quite weak compared to the gravitational forces, which are humongous near a black hole. And so all the various properties of black holes that you've read about, the fact that they can collide and form bigger black holes, nothing can come out, and things like that, is due to gravity and not charge. And we know this because we actually have a solution of Einstein's equations that is charged.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. You're not going to get a busy signal. In fact, 24/7, anytime, day or night, you can call that number, 866-323-2129. And just remember that all we ask of you is that you leave your name, call letters of the radio station, and the city you're calling from, and perhaps your thoughts can be heard on national radio. In other words, if it's 4 o'clock in the morning and you suddenly get that brainstorm and you just got to talk to somebody, and yet it says to you in an empty room, well, you can talk to me. You can give me a call by calling 866-323-2129, and you can possibly get on national radio. Okay, well, let's move right along and take the next listener phone call.
My name is Keith. I'm from Kennewick, Washington, listening on 610 AM, KONA, and I was wondering, what makes space so cold? I mean, we have suns that heat them up, and, well, you can feel how hot it is here, and we're millions of miles away. I don't understand why they're so cold. Planets are molten in the middle, so there's some heat. Thank you. Bye.
Well, you ask an interesting question because, of course, planets can be hot, volcanoes can be hot, stars can be hot, but space is very cold. And so why is that? Well, first of all, we know the temperature of outer space. If you were to get a cosmic thermometer and go into deep space, you would find that the temperature of outer space is about 3 degrees above absolute zero. Very cold. And why is that? Because, yes, we have stars, we have planets, but most of the universe is empty. That's right. Most of the universe is empty. If you were to calculate the average density of the universe, it would be a few hydrogen atoms per cubic meter. And so, in other words, the universe is basically made out of nothing. the universe is basically mostly a vacuum. So yes, there are stars, yes, there are planets with volcanoes, but they're tiny compared to the huge size of the universe itself. And then the question is, well, why is the universe at 3 degrees above absolute zero? And the answer to that is, that's the temperature of the Big Bang today. Believe it or not, we are looking at remnants of the cosmic explosion that created the universe itself. We measure this. In fact, our satellites, like the COBE satellite and the WMAP satellite, have given us extremely accurate photographs of this microwave background radiation. It is the explosion. It is the explosion which created the universe. Baby pictures of the original fireball. And if you want to see pictures of this, go to nasa.gov, look under either WMAP or COBE, C-O-B-E, and you could see the map that was created of this radiation. Now, if your eyes could see microwave radiation, if your eyes could see microwave rather than visible light, when you look at the night sky, you would actually see the explosion. You would see this gigantic fireball illuminating the entire night sky. But unfortunately, the universe is cold now because it's been quite a few billion years since the Big Bang. And as a consequence, you cannot see the microwave radiation. But if you had eyes that were quite big and had microwave eyes, then you could see the original fireball lighting up the night sky every night. And so even though stars do tend to be hot, planets have volcanoes, and yes, the center of the Earth is very hot, they are minuscule compared to the total size of the universe, making the universe quite cold and making the heat of the universe itself is a remnant of the Big Bang. In fact, another remnant of the Big Bang is the static you see on an old TV set. If you hear that static on a radio or the snow on a TV set, most of the radiation comes from Jupiter, but a small fraction comes from the Big Bang itself. Amazing.
Science fantastic. Michio Kaku. You are listening to Science Fantastic with Professor Michio Kaku. Trouble with the old particle accelerator? Not a problem. Dr. Kaku will get you spinning.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Why not join the fun? Why not give us a call by calling 866-323-2129 and making a comment or asking a question about science. And while I'm at it, why don't you go to my website? It's mkaku.org, mkaku.org. You can go to my Facebook site at Michio Kaku. And on Facebook, we have almost 3 million fans on Facebook now. Or go to my Twitter account. And on Twitter, we have about 300,000 people taking Twitter. And what is the excitement about? Well, I've written several New York Times bestsellers, 3 of them, in fact. The latest is called The Future of the Mind. Find out about all the mysteries of the human mind decoded because of advanced physics. Physics allows us to peer right into the thinking process of the living brain. Think about that. Telepathy, telekinesis, recording memories, uploading memories. We can do all of the above in physics laboratories, and find out how by going to my website, mkaku.org, mkaku.org. Okay, well, let's move right along to the next listener phone call.
Yes, this is Vince. I listen to 1470 AM News Talk, WFNT, out of Flint, Michigan. I would like to know, if sugar is made from plants, which is the most common plant is used to make sugar? What is the healthiest type of sugar? And is brown sugar better for you than white sugar? Thanks, bye.
Well, I think what you're getting at is that sugar comes in many types, And what sort of differentiates some of these types of sugar? Well, first of all, if you just go to the internet and type sugar, you can see the molecular structure, and it's basically repetition of one basic structure. Glucose is the simplest of the sugars, and all the other sugars that we see, plant sugars, fructose, lactose, things like that, all the other animal and plant sugars are combinations of glucose. And so when you ingest sugar, the body breaks down these components down to its basic, which is glucose. And as far as brown sugar is concerned, in some sense, you can look at the brownness as being basically dirt. It's contamination. So pure sugar is white. But, of course, when you harvest it in the rough, in the wilderness, there's going to be contaminations, and some people think that's healthier. Well, who knows for sure, but of course it would have a certain amount more of certain minerals because of the fact that the brownness of brown sugar is caused by impurities rather than being a pristine form of sugar. Sugar by itself is basically white, and glucose is the basic sugar of all. And then the question is, well, why do we react so positively to these plant sugars and animal sugars? Glucose, for example, is the basic chemical, but lactose is found in milk. And we also have fructose and other kinds of plant sugars. Well, there's an evolutionary reason for this, and that is that plants evolve sugar in order to be eaten so that their seeds will be transported to different realms. In other words, sugar probably predates the human race. The human race itself is only a few 100,000 years old. Before that, we were not human at all. But if you take a look at the plant and animal kingdom, these sugars predate humanity. And so why did plants create sugar? To be sweet, to be attractive to animals, so animals would eat the fruit, carry the seeds to different realms, and accelerate evolution.
I'm a scientist.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, you can be part of the fun by giving us a call at 866-323-2129. And just remember that no question is, quote, too dumb or silly to put on national radio. For example, a 23-year-old gentleman about 300 years ago asked himself a simple question, and that is, if apples fall, does the moon also fall? Well, that 23-year-old gentleman happened to have been Isaac Newton. And when he answered that question, does the moon also fall, he initiated perhaps one of the greatest revolutions in all of human history. He invented mechanics, the laws of the solar system. He allowed scientists to be able to calculate the properties of machines, and that led to the Industrial Revolution, which changed the course of modern history. Think about that, a world without machines. That's what it was back before the days of Isaac Newton. And it all started when Isaac Newton asked himself a question that only children would ask, and that is, does the moon also fall? And the answer is yes. The moon is in free fall. It doesn't hit the Earth because the Earth, of course, curves beneath it. But yes, the moon is in free fall. And that allowed him to calculate the motion of all the planets in the solar system. Okay, so moving right along now, let's take the next listener phone call.
This is Dan, 610 KNDU in West Richland, Washington. I worked 30 years at Hanford and 20 years in the encapsulation building where we encapsulated strontium and cesium. And my question is, why does cesium glow blue when it's in double-walled capsules when it's in 13 foot of water? If you turn out the lights, the capsules will glow soft blue.
Well, you ask a very interesting question. If you ever go by a commercial nuclear power plant, and gain access to the site, and you ask, where is the spent fuel pond, where they take the used fuel rods and put them in a swimming pool, and you look down into that spent fuel pond, you'll find there's a bluish glow. Or for that matter, if you go to a research reactor and you can actually see the core underwater, you can see that it glows blue. And why is that there's this blue, eerie blue color? That's called Cherenkov radiation. It's when particles go faster than the speed of light in water. Now, you may say to yourself, well, how can that be? According to Einstein, nothing can go faster than the speed of light. Yes, but you see, in water, light slows down as it goes between molecules. So the speed of light, the average speed of light, I should point out, is less than the speed of light in the vacuum because light has to interact with all the atoms of water. Therefore, you can go faster than the speed of light in water. Now, when you do that, you create a shock wave. Think of an airplane. When an airplane goes near the speed of sound, the sound waves in front of the airplane build up because you're approaching the speed of sound. And when you burst through all these accumulated sound waves, you create a boom, a sonic boom, and then you create a shock wave as you exceed the speed of light in air. So that's why we have sonic booms, and that's basically the principle behind what happens when you exceed the speed of sound in air. Now, light slows down on average in water. Therefore, it is possible to go faster than the speed of light in water. Therefore, there should be a shock wave, and the Russian physicist Cherenkov calculated the properties of this radiation, and bingo! It matches perfectly the radiation that you see glowing from a nuclear power plant, not just cesium, but any nuclear power plant that contains intense amounts of radiation will, in fact, create shock waves that glow in the blue range. Now, this is also a safety issue because, believe it or not, on several occasions at American military installations, enough fissionable material was concentrated at one point to create a mini atomic bomb. Now, of course, this was not a true atomic bomb with blast that could wipe out a city like Hiroshima. It was basically what happens when you exceed critical mass. Now, it turns out the radiation from this concentrated quantities of plutonium, the radiation was sufficient to exceed the speed of sound, speed of light in air to create a blue glow. These are called accidental criticality accidents, and unfortunately, a handful of them have actually taken place in the United States. This is not commonly known to most people. Most people think that there has never been a fatal nuclear accident in America. That's not true. The correct statement should be there has never been a fatal commercial nuclear accident. But nuclear weapons accidents, yes, they do occur. Most of them, for example, occurred at Oak Ridge National Laboratory in Tennessee. And the people who witnessed accidental criticality all say the same thing. There was a blue flash of light as critical mass was exceeded on a small scale. The people involved, of course, were hit with lethal amounts of radiation. Huge blisters formed on their bodies, and they basically died of tremendous quantities of radiation poisoning, thousands of rads of radiation coursing through their bodies. And what people saw when it happened was a blue glow. That is Cherenkov radiation.
The most up-to-date announcements and analysis from today's technological leaders every week on Science Fantastic. The cosmos, space, and time travel, medicine, robotics, science, and technology. Professor Michio Kaku, theoretical physicist, graduated from Harvard University summa cum laude and first in his physics class. Received his PhD in physics from the University of California at Berkeley. And now, a professor of physics at City University of New York for 30 years. His goal? To complete Einstein's dream of a theory of everything, to derive an equation, to summarize all the physical laws of the universe. The co-founder of string field theory, author of the international bestsellers Hyperspace, Visions, and Parallel Worlds, and voted as one of the 100 smartest people in New York, profiling the latest cutting-edge developments in science, which revolutionize our world and touch our lives. Now, Science Fantastic with Professor Michio Kaku.
Welcome. Once again, this is Dr. Michio Kaku, and this is Science Fantastic. On Science Fantastic, we profile some of the most amazing developments in science. And in this hour, we're going to talk about the search for aliens in outer space. We're not talking about UFOs. We're talking about the science of how hundreds, thousands of scientists around the world are interested in revealing some of the greatest secrets of the universe. Are we alone in the universe? And once again, we should also point out that I'm always on tour around the country, so go to my website, mkaku.org, mkaku.org. Maybe I'll be in your city signing your copy of my latest paperback book, a New York Times bestseller called The Future of the Mind. Telepathy, telekinesis, recording memories, uploading memories, all the stuff you see in science fiction movies. Did you know that we scientists can actually do in the laboratory? Find out by going to my website or go to my Facebook site. We have 3 million followers on Facebook and 500,000 people follow me on Twitter. Well, once again, in this hour, we're going to bring on Dr. Seth Shostak, senior astronomer at the SETI Institute. If you were to single out one man, one individual that is perhaps the most prominent in the search for alien life in outer space, it would be Dr. Seth Shostak, author of a number of books, including Confessions of an Alien Hunter and Life in the Universe. He made headlines a while ago by stating that in 20 years time, he predicted we will make contact with an alien civilization in outer space. And did you know that there have been strange, anomalous signals that have baffled professional astronomers? Last year, a gigantic object apparently eclipsed the mother star, many times bigger than the planet Jupiter. Some people say that only an artificial object could have done that. And then the Russians just a few weeks ago announced the fact that they picked up some bizarre, anomalous radio blip from outer space. Only a civilization thousands of years more advanced than us could have done such a feat of radio telescope technology. Well, what is the science behind all these things? Many people email me, and my advice is that if you've ever been abducted by a flying saucer, you should steal something, a paperweight, alien chip, anything so that we scientists can analyze it. Or you can contact the SETI Institute, which is what we're going to do in a minute. Once again, give us a call at 866-323-2129 if you want to get on Science Fantastic and ask your questions about science. Once again, this is Dr. Michio Kaku. Stay tuned. After the commercial break, we're going to talk about the search for alien civilizations in outer space, told to us by a PhD physicist, Dr. Seth Shostak.
You're listening to Science Fantastic with Professor Michio Kaku. Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to talk about, well, aliens from outer space. We're not talking about a science fiction movie. We're talking about physics and astronomy in this hour. We're very delighted to have with us once again Dr. Seth Shostak. He is the senior astronomer for the SETI Institute. And SETI stands for the Search for Extraterrestrial Intelligence. That's right. In this hour, we're going to talk aliens from outer space from the point of view of an astronomer. we should point out that Dr. Shostak got his bachelor's degree in physics from Princeton, PhD in physics from Caltech, and is the author of a number of great books, including Confessions of an Alien Hunter and Life in the Universe. And if you want to know more about his work, go to a website, bigpicturescience.org. So, Seth, once again, glad you could be on Science Fantastic.
Terrific, Michio. Always enjoy it.
Okay, well, again, here's a question that we always ask our guests, and that is, how did you as a youth now, when you were very young, what steered you in the direction of science?
Well, I think that kids get interested in something between the ages of 8 and 11. It may be hardwired into us, who knows, but that's certainly what happened to me. I was interested in science only because, my father had a job in which he was, kind of a scientist, actually, but he also had an interest in electronics, so I was interested in that right from the get-go. But the thing about science was that it explained things you saw every day, right? And that was kind of like magic for me. At age 8, I do recall pulling it was a book of maps, actually. It was just an atlas that my parents had off the shelf, and in the back was a diagram with a bunch of concentric circles in it. And I remember asking my mom, what are these circles? And she said, oh, those are planets. I had never heard the word, but within 2 years, I built my own telescope. So I got interested in astronomy very early.
Okay, well, then you went on to get a Ph.D. in astrophysics from Caltech. I remember when I got my Ph.D. in physics from Berkeley, first thing I had to worry about was getting a postdoc, an assistant professorship, and getting tenure, and that whole route. However, you took a slightly different path. Explain.
Yes, well, I did. Well, I am unfortunately cursed with too many interests. I don't recommend that to anybody, but, it makes you maybe more interesting at cocktail parties. I don't know. But I've had many different kinds of jobs. I was able to get a postdoc, as it turned out, after my degree work at the National Radio Astronomy Observatory. They were headquartered, and still are, by the way, in Charlottesville, Virginia. And they had radio telescopes around the country, actually, both in West Virginia and in New Mexico. And so I knew people there because of my thesis work, and they offered me a postdoc, which I took, and enjoyed that greatly. But after that, I did other jobs and eventually took a job at a university in Europe and came back to the United States. And during that time, I developed an interest in the idea of SETI, the Search for Extraterrestrial Intelligence. And when I was in the Bay Area, somebody found out I was there. They called me up and they said, you want a job at the SETI Institute? And they called it the right time.
I see. Okay. And so in your heart of hearts, you really believe they're out there, right?
Well, I do, Michio. If I didn't believe that, we're located in the Silicon Valley, south of San Francisco. I think anybody could walk across the street and double their salary. The SETI Institute is a nonprofit. We run a lot on donations and so forth. So the remuneration isn't very high. So if people weren't interested in the subject matter, I don't think they would do it, to be honest. So, of course, I think that there's somebody out there to be found.
Okay. And, of course, there's something called the giggle factor. You talk to a, quote, reputable, unquote, scientist about aliens from outer space, and their eyes kind of like roll up to the heavens, and they kind of like giggle, and at that point, that's the end of the conversation. But you really think that science can reveal the presence of aliens in space?
Well, it certainly works on paper that the experiments could do that. And as far as whether they're really out there, one of the things that we've learned in the past, really 5 years, is that most stars have planets. We didn't know that when I was a kid, going to the Hayden Planetarium in New York. They, would occasionally tell you, planetary systems might be very rare. There might not be many planets out there. Well, we know that's wrong now, and the number of planets in the Milky Way galaxy is on the order of 1 trillion with a T. That's a big number, and, most of them are not terribly interesting for life, but maybe 1 in 5 stars, that's the current estimate, 1 in 5 stars might have a planet sort of like the Earth. So if we're the only planet where you have not just life, but intelligent life, then, we really won the lottery, and it's hard for me to believe we won the lottery.
Okay, well, let's back up a little bit now and talk about something called Drake's equation. We've talked about it on Science Fantastic before, but let's talk about it. What is Drake's equation, which sort of sets the tone for the scientific investigation for SETI?
It does, in fact, and you'll find Drake's equation in just about every astronomy textbook. It's said to be the second most famous equation in all of science, the first one being E equals mc squared from Einstein. But Drake's equation was just an agenda for a meeting that astronomer Frank Drake cooked up in 1961. He had a meeting with only about a dozen attendees, but these were all pretty high-powered scientists, to discuss the whole matter of, well, could there be somebody out there and could we ever find them? And in order to sort of organize the meeting, he came up with this little formula that estimates, well, how many societies are out there in our own Milky Way galaxy that could be broadcasting signals going through our bodies as we go about our business today. And so, it includes how many stars are out there with planets and what fraction of those planets are habitable and what fraction of them are actually inhabited and how many of those planets have cooked up something intelligent that can build a radio transmitter. All these factors, there's 7 factors, in the Drake equation are used to estimate, how many broadcasters are out there. And while we don't know many of the terms in the Drake equation, it's a great way to organize the subject, that's for sure.
Now, you mentioned some of the numbers, right? Now we have the Kepler satellite up there orbiting the sun, which gives us, for the first time in history, a census, a rough census of the number of planets that we might have in the Milky Way galaxy that may sustain life. So how has the Kepler satellite revised Drake's equation?
Well, Kepler is often said to be one of the most, effective science projects that NASA ever put together. Its job was just to find out how many stars like the sun, so sun-like stars, had planets sort of like the Earth. Okay, and they're still working on that. But it turns out that Kepler has been able to find thousands of planets in our Milky Way. Okay, that's kind of interesting, but the really important thing is not how many planets it's found, it's what fraction of stars have planets. And that turns out to be the majority of them. Maybe it's 70%, maybe it's 80%, maybe it's close to 100%, but there are a lot of planets out there. Now, trying to decide what fraction of those planets are the kind you'd like to live on, the kind you'd like to build a condo on, that's much harder because those planets tend to be small and hard to find. But the best estimates are maybe 1 in 5. Now, it could be 1 in 10, it could be 1 in 2, but it's not 1 in a million. That's the point. So there are lots and lots, tens of billions of cousins of the Earth just in our galaxy, and I remind everyone that there are at least 150 billion other galaxies we can see. So, there's a lot of real estate. That's the bottom line.
So, in other words, the probability of having a doppelganger of the Earth in outer space is pretty close to 100%. That's what you're saying, right?
Well, yeah, it's either that or you have to say there's something very, very special about the Earth. And anybody in science knows that if you say, well, we're living in a miracle, you can't get your paper published if that's the basis of your argument, right? Scientists like not to believe in miracles. You usually assume that whatever you're experiencing is somehow fairly common, just on statistical grounds. And, of course, we don't know that for sure. But, on the other hand, that's a much safer assumption in my mind than to assume that Earth is somehow very special.
Okay, now let's talk about SETI in particular. Many people think that we must have thousands of radio telescopes scanning the heavens, but it's all funded by private donations, right?
It is, actually. When I joined the SETI Institute, that was the very early 1990s, it was still a NASA project. But that was killed by the U.S. Congress in 1993. In this month of 1993, in September, as I recall, but maybe it was October, whatever. So that ended the public funding of the SETI search. It was never very expensive, by the way. It was always a tiny, tiny fraction of the NASA budget. But since that time, the SETI experiments in the United States, and that's just about the only place where they're being done, have all been funded by private donations, people who will send you a $20 bill or something like that. It's a difficult way to conduct science, but that's the way it is.
Okay, well, before we continue, is there a website or a place where people can donate money to the SETI Institute?
Oh, absolutely. It's just SETI.org. Just type that into your browser and you go right to the SETI Institute.
Okay, now some people think that we must have teams of people scanning thousands and thousands of stars. But my understanding is that we've only scanned maybe roughly 1,000 stars with any degree of accuracy. What is the state of how many stars we have scanned?
Well, it's true. People imagine that this is a worldwide project and that, as you described, thousands of white lab-coated scientists with clipboards, doing this work. Of course, they get that impression from the movies, I suppose. But the total number of people in the world whose job description is to do this kind of work is very small, maybe a dozen in total, maybe not that many. And they're mostly in only 3 places. Places actually. One is Harvard, one is the University of California at Berkeley, and the other is the SETI Institute. And a lot of that is simply due to the lack of money, of course. That's why it's very small. And we've looked at, yes, on the order of thousands of nearby star systems over a wide range of the radio dial, over a wide range of the spectrum. So, indeed, it's very early days, and the fact that we haven't found a signal, I think, is simply attributable to the fact that we've only begun the search, so to speak.
Now, many people understand how SETI works from the movie Contact, starring Jodie Foster. How accurate was that movie? And did you like the ending of the movie where they actually, I guess, teleport to this planet and meet the aliens who look just like us?
Yeah, well, it's always important to meet the aliens. If you've been teasing the aliens throughout the whole movie and you never meet them, I don't know. I think you buy less popcorn. I'm not sure. The movie was pretty accurate, at least in the science part of it, which is to say the SETI part of it. But, of course, it was based on a 1983 novel by Carl Sagan, and Sagan knew very well about SETI. He was even on our board of directors for a while just before his death. So he, of course, knew the subject material, and he was a scientist. So, yes, that's accurate. I mean, building this giant, what looked like a Coney Island carnival ride that you could drop into and somehow get transported through a wormhole into space, that's fiction, of course. And the fact that the aliens kind of look like us, I think they were dressing up to look like us. Who knows what they really look like? You never see them in their sort of natural habitat. But I enjoyed it, of course, but it's fiction.
Okay. Now, we also had a physicist, Paul Davies, on our airwaves a while ago, author of the book, The Eerie Silence. And his point of view is that, well, where are they? We don't pick up signals from these beings that should be flooding the Milky Way galaxy with their stray radio signals. What is your thought about the so-called eerie silence or the Fermi paradox?
Yeah, well, I don't think it's so eerie, with all due respect to Paul, who's, of course, very knowledgeable on this. But, you look at our own what's called leakage radiation, which are the transmissions we send willy-nilly into space, not because we're trying to reach aliens, but only because, we're trying to serve our own interests, such as television, FM radio, or for that matter, even radar. Most of those are becoming less and less powerful as our technologies get better, right? You're not going to have those big antennas on the hills outside of town forever because, broadcasting isn't the way you probably get your television even today. So it could be that most alien civilizations are relatively quiet. Of course, radar is something you always need. You always need radar because without radar, you can't, look at incoming comets and things like that. So I don't know how much leakage you should even expect from the aliens if they're very sophisticated, if they're 100,000 years more advanced than we are. Maybe they're, generally speaking, pretty quiet. I don't think that means much.
Okay. Now, also, as pointed out by other people, the Earth also radiates. We've been radiating I Love Lucy into outer space. We'll take a short commercial break, but after the break, I'll ask you a question. Isn't that rather dangerous when we don't know what their intentions are, advertising our existence to the aliens in space? Okay, let's take a short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. Hotline number is 866-323-2129. And all we ask is that you leave your name, call letter to the radio station you're listening to, and the city you're calling from. But perhaps you can get on over 100 radio stations that carry Science Fantastic. So stay tuned, because in the next segment, we're going to talk about strange signals that some people think come from advanced civilizations in outer space.
Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we are talking the science behind aliens from outer space. And we're talking to the dean of the SETI search. We're talking to the senior astronomer for the SETI Institute based in Silicon Valley, Dr. Seth Shostak. He got his bachelor's in physics from Princeton, PhD in physics from Caltech. And as I mentioned, he is a senior astronomer for the SETI Institute and the author of a number of great books, including Confessions of an Alien Hunter and Life in the Universe. And if you want to contribute to the SETI Institute, go to SETI.org. Well, we last left off, Seth, we were talking about, well, isn't it dangerous to advertise our existence to aliens from outer space who could be more advanced than us? Stephen Hawking, our colleague, has said that, well, the history of the Earth is full of sad examples of an advanced civilization encountering a less advanced civilization with horrific consequences. So what are your thoughts about whether it's wise to, quote, advertise, unquote, our existence to aliens in outer space?
Well, indeed, Michio, this is a very controversial topic with people getting very emotional on both sides, actually, because there are some people who would like to broadcast. I might point out that SETI experiments involve no broadcasting at all. They're just listening experiments. The SETI Institute uses an array of antennas in Northern California, about 300 miles north of San Francisco, called the Allen Telescope Array. And, you know, there are no transmitters on that array, so there's no broadcasting at all. We're just listening. But on the other hand, there are people who do want to broadcast as an experiment, and there may be value in that, at least in terms of learning something about the difficulties of transmission. That might be useful, actually. But there are others who say, oh, no, don't do that because then you'll betray our presence, and who knows what's out there. You have no idea what's out there, and, you might tick them off, and they come to Earth and, incinerate Weehawken, New Jersey, just on a bet. I mean, there are all these possibilities that sound pretty dangerous, and as you mentioned, Stephen Hawking has even said, be careful. I don't really agree with any of that because I think it's very easy to convince yourself that any society that could pose a danger, any society that could somehow threaten the Earth from tens, hundreds, even thousands of light years away, because that's what you're talking about, they're much more advanced than we are, and they'll have bigger antennas, and they'll be able to pick up, as you mentioned, I Love Lucy, or at least the radars from the local airports. So if you're really worried about that, you have to turn all that stuff off. And it's too late anyway. And besides, anybody want to turn off the radars at the New York airports? I don't think that's a good idea. So I don't worry about this much.
Okay. Well, let's move right along because there have been several anomalous things happening in outer space that have tantalized UFO hunters. First of all, last year we had a star about 500 light years from the Earth, which was eclipsed or transited by an object that went in front of the star, dropping sunlight by, 15% or so? Now, a Jupiter-sized planet orbiting in front of a star will diminish starlight by maybe 1%, and that's Jupiter size. Here we have something which dropped starlight by maybe 15% or so. Humongous amount. Some people think that only a very advanced civilization could have done that. But what are your thoughts? So far, I have not heard any credible explanation of this bizarre, anomalous event in outer space.
Well, indeed, and it's been in the headlines quite a bit. It's a star known as KIC. What is it? 28. What is it? I don't even remember the number. I used to know it, but it's 1,470 light years away. So it's almost 1,500 light years away.
1,500.
Yeah, well, it's pretty far away, and it was observed by Kepler. Okay, and I think it's 846-2852. My brain may have kicked in gear there. Anyhow, it has a very uninteresting name. It's hard to pronounce, but it's a star that indeed has witnessed drops in brightness by as much as 22%. Now, that is, as you point out, a lot. That's not a planet passing in front of it. And there was a whole laundry list of possible explanations for what was happening here, including, dust from comets and so forth and so on. None of that has panned out. we've looked at it with the Allen telescope array. We didn't find any signals, but on the other hand, this star is pretty far away, so the transmitters would have to be very powerful for us to pick up anything. So what's the bottom line? The bottom line is we don't know what the bottom line is because we don't know what's going on here. There have been claims in the press this week that a second second star system has been found that also exhibits these occasional big dips in brightness. So could it be that there's an advanced society there building some sort of Dyson sphere, Dyson swarm around this star, some sort of alien megastructure that's blocking the light? Yeah, it could be. But people should keep in mind the history. You know, we've had lots of discoveries by astronomers in the past where we didn't understand what was going on. After all, that's the job of astronomers, really. And the first conclusion that many people will jump to is alien activity. But it has never been alien activity. The pulsars were not aliens. The quasars were not aliens, and yet aliens were used to explain them. So my guess about what's going to happen is we're going to find a couple of more stars like this, and then some clever theoretician is going to figure out what's really going on.
Okay, well, let's take another short commercial break. And after the break, we're going to talk about more anomalous signals coming from outer space. What's happening out there in the universe?
You're listening to Science Fantastic with Professor Michio Kaku.
Science Fantastic with Professor Michio Kaku. Our special guest today is, quote, an alien hunter. Author of the book, Confessions of an Alien Hunter, Dr. Seth Shostak, senior astronomer at the SETI Institute. Author of a number of great books, including Life in the Universe and Confessions of an Alien Hunter. And he's a senior astronomer at the SETI Institute, the search for extraterrestrial intelligence. Well, where we last left off, we were talking about the possibility of, well, a Dyson sphere. Tell us a little bit about what is a Dyson sphere, and do you think it could really cause a drop in starlight by 22%?
Dyson sphere is named after Freeman Dyson, a very well-known British physicist, actually, who's had a lot of very clever ideas. And one was that, look, if you consider how a really advanced society deals with its energy shortages, you know, it doesn't dig up more coal or anything like that. What it does is it, you know, fills the space in its own solar system with solar panels, right? And in fact, you could imagine building a giant shell. I mean, maybe you take apart Neptune or some other worthless planet for the materials, and you build a giant shell outside the orbit of your own planet and just line the inner side of it with solar cells and then beam the energy they collect back down to your planet so that you have all the energy you can possibly use. Well, I mean, that would work in principle. Probably a shell doesn't work for reasons that have to do with, you know, some elementary physics. But on the other hand, this idea is a good one, and if we really want to solve our energy problems, we'll eventually do the same thing. We'll just put up solar panels in space and beam the energy down. You don't burn anything. It's great. Well, maybe some advanced society had done this, and they have a partially completed Dyson sphere because they don't need all of it. And occasionally, just because this Dyson sphere is in orbit around the star, it gets in the way and it blocks some of the sunlight. So that was the explanation. And sure, it could be true, but on the other hand, many other things could be true.
Now, one possibility was a comet swarm. How can a comet swarm drop starlight by 22%?
Yeah, you'd need a lot of comets, and that's the problem. You might need hundreds of thousands of comets if they're kind of the same size as the comets we know about. And not just having comets, you know, just sort of rocks in space, because that would take an awful lot of rocks in space to block 22% of the starlight. But if the comets are close enough into the star that, the star is kind of boiling stuff off the comets, including a lot of dust, well, maybe you could get a lot of dust. It's sort of like, a fire producing a lot of smoke that can block sunlight. So that could be, but if that's the case, then you would expect to see the dust, maybe not directly, but you would see what's called infrared radiation coming from that star system, and we don't see much. So I don't know. There are people who still think that's a good explanation, but many others are not convinced.
Okay, well, let's take another short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Our special guest today is Dr. Seth Shostak, Senior Astronomer at the SETI Institute. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking aliens from outer space. Well, Seth, we talked about a potential of a Dyson sphere orbiting a star in outer space, and then the Russians. The Russians detected a signal from a star, a huge signal, perhaps from a civilization thousands of years more advanced than us, that was picked up but never duplicated. What are your thoughts now about this signal, which was reported by a Russian radio telescope installation?
Yeah, well, indeed. I learned about it just a little over a week ago when I got an email from some guy in Italy who said something about this. He said, you ought to check this out. And he actually sent a graphic, a plot, showing the signal that the Russians had picked up using their Ratan 600 telescope. Now, the Ratan 600 telescope is a very big radio telescope near the Caucasus Mountains, and I've actually been there. It's kind of interesting to see. It's kind of a Soviet-era telescope. But the people who are using it, the Russian radio astronomers, they're competent people. If they found a signal, there was a signal. I mean, you know, they're not going to lie about that. But it's also the case that if you've got a big antenna and sensitive receivers, you pick up signals all the time. And they're usually due to, you know, telecommunication satellites, actually. So my first thought was, well, they only saw it once. It's probably just interference from a satellite. But that wasn't what they were saying. They found it more than a year ago. They didn't tell anybody. So what's going on? Well, somebody wrote a blog, and the whole thing went viral. So we started using the Allen Telescope Array to try and track down this signal, and the folks at the University of California in Berkeley used a big telescope in West Virginia to try and track it down, and none of us could find it. So, you know, this was a big media blitz because the media thought, well, maybe we found ET. It turns out that the Russians say that what we found was a Soviet military satellite, or maybe not even Soviet, but at least a Russian military satellite, and I'm inclined to believe them.
Okay. Well, let me ask you a question that you've been asked many times before, and that is the protocols of what happens when one day we do make contact. Of course, the movies have all the sets of protocols with the President of the United States, the Joint Chiefs of Staff coming into the game. What is protocols, if there are any at all, concerning what happens when we do make contact?
Well, there are some protocols, actually. In fact, I was the chair of an international organization, the International Academy of Aeronautics and Astronautics, and we did put together the protocols. It sounds very evil, the protocols, but it's a 3-page document, actually, and it has no force of law. I mean, we tried taking it to the United Nations, and they say, well, just put it in that file cabinet over there. I mean, you know, the United Nations is apparently has no interest in dealing with this thing. So there's nothing you can do to enforce these things. It's just kind of a gentleman's agreement, right? It isn't even as strong as those blue book pledges you would sign in college where you promise not to cheat on an exam. But all they say is this. They say, if you find a signal that looks interesting, the first thing to do is to check it out. Well, okay, that's just good science, right? I mean, you want to make sure that what you found, you've really found. The second thing is tell everybody. Okay, that's legitimate too. And the third thing is don't broadcast anything back without, you know, telling the whole world what you're doing. Okay, this is apple pie and motherhood, all of it. But I can tell you on the basis of false alarms, including this Russian signal from last week, what really happens if you find an interesting signal is that people go on their blogs or they're on Twitter or whatever, and it's all over the world, and the media start calling up and want to know more about it. So the protocols, while a nice idea, you know, there are a lot of nice ideas like good table manners that get flaunted all the time.
Well, in the movies, of course, the Joint Chiefs of Staff, the President, the National Security Council, they all meet together and they say we cannot reveal the information because panic would ensue. I mean, there's no basis in that scenario, what you're saying, right? It's going to be all over the place almost instantly. What are your thoughts?
That's correct. And this idea that the government would, you know, swoop down and shut everything down. To begin with, the evidence is up in the sky, so they can't exactly hide that, right? And you wouldn't believe it yourself unless a couple of different radio observatories, probably around the world, checked it out too. So, the idea that you could keep it secret is kind of goofy to begin with, but also the idea that the public would, start rioting in the streets. We've had a couple of false alarms, I guess I should call them, signals that we thought were real. And, I kept waiting for the men in black to show up or maybe somebody from the Pentagon to call up. None of that happened. None. What did happen is that the New York Times started calling up. So, they didn't run with the story because it turned out it was just interference from a satellite. But, maybe the Weekly World News would have run with this story. So I think if we do start finding a suspicious signal, you'll hear about it in the checkout line of your local supermarket first.
You were quoted as saying that I think within a 20-year time span or something like that, you do expect contact to be made. Do you still make that claim?
Yeah, I bet everybody a cup of coffee that we would do that. And I may owe a lot of cups of coffee in 20 years. I'm not so sure. But in any case, the reason I did that was simply on the basis of the improvement in the speed of the experiment, right? Because SETI depends a lot on digital electronics, or if you will, computers. And, of course, they're getting faster all the time. And so looking at the future of what computers would be able to do over the course of the next 20 years, it's easy enough to estimate that if SETI gets enough money to keep going, we could look at 1 million star systems in the next 2 decades. And, it's just a gut feeling and nothing more than that. But my gut feeling is if you look at 1 million star systems, then I think there's a decent chance of finding a signal. So that's why I bet everybody a cup of coffee that will happen.
Okay, and also the future. What do you think holds for the future in the next, let's say, 20 years for the SETI Institute? More private money coming in, more telescope expansion, more stars analyzed. What are your thoughts?
Well, I certainly hope that all of that will be true, obviously. I might point out, by the way, that the SETI Institute does a lot of research that's called astrobiology, and that is funded by NASA. That's looking for life on Mars or some of the moons of Jupiter and Saturn and so forth. So, there might be life really nearby. It's just not going to be of the intelligent variety. It's most likely going to be microscopic life. But on the other hand, we can get to it with our rockets, so that makes it particularly interesting. So that will, of course, keep going on. But the SETI experiment, which are privately funded and totally dependent on donations, well, it depends on the funding. I remain perennially sanguine.
An optimist, right? Okay, well, unfortunately, we've run out of time. Once again, our special guest is the senior astronomer at the SETI Institute, Dr. Seth Shostak. Go to SETI.org, SETI.org, and find out about the search for extraterrestrial intelligence.
Now, Science Fantastic with Professor Michio Kaku.
Welcome to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because this hour is your hour. This is the time when you can get to the phones and give us a call. On Science Fantastic, not only do we answer your questions that you may have when you call 866-323-2129, we also bring on some of the world's top scientists, and we summarize some of the big science stories that have hit the headlines in the past week. For example, one of the big headlines concerns anti-aging. Yes, it turns out the scientists are now zeroing in on yet another chemical that at the level of yeast cells can extend their lifespan. So now people are beginning to use these chemicals on mice and dogs to see whether we can reinvigorate them and reverse the aging process. We experiment on mice and dogs, however, because, well, to be very frank, they don't live so long. We live so long in comparison that it's very difficult to do experiments on human beings. Let me explain. If you eat 30% less calories, you live 30% longer. This has been verified in yeast cells, in spiders, insects, flies, in dogs, cats, rats, animals, mice. In fact, we've done it now on primates. When you feed primates in a cage 30% less calories, they live 30% longer. And then the next question is, why don't we try it out on humans? Well, you can figure that out. We humans sue if we get discomforted. Who can eat 30% fewer calories? Who wants to live like that? You live like a hermit for the most part. And I should point out that animals fed this diet, they become lethargic. Their body temperature dampens a bit, and they become slower, and they lose all interest in sex. Sorry about that. That's one of the reasons why it's very difficult to do these experiments on humans, because we humans sue. We don't like it, we sue them. And we are an ordinary bunch of animals, and therefore it's quite difficult to experiment on us, and we live so long. Mice, they only live on average of maybe 2 weeks. Insects, some insects only live for a matter of days. So it's easy to do experiments on them, and a lot of experiments are done on worms and yeast cells. So many of the stories you read about in the newspaper about enzymes like resveratrol and, for example, telomerase, things that were big fads a few years ago with people thinking that that's the fountain of youth, well, shock. We find out that some of them are not reliable. That is, we cannot use the results of worms and yeast cells and extend them to think that we have the fountain of youth for human beings. Now, personally, I think it's possible to extend the human lifespan. However, I'm rather skeptical about some of the claims being made that this vitamin or that mineral will all of a sudden become the elixir of life. However, on Science Fantastic, because we are a science program, we will profile some of the latest studies being done on the aging process to see whether or not one day in the future, we may actually be able to slow down and even reverse the aging process. For example, many reputable scientists believe that our grandkids, not our generation, sorry about that, but our grandkids may have the option of hitting the age of 30 and then just stopping. They may like being 30 for several decades. Who wants to get old and decrepit? Who wants to see your body parts slowly fail and not work anymore? Well, that's the promise of the anti-aging experiments being done in the laboratory. But do we have a winning formula at the present time? The answer is no. In fact, the studies being done on dogs this week, which made the New York Times, it was so sensational, you have to take it with a grain of salt. Maybe, maybe not. But so far, we have yet to find a reproducible, reputable, falsifiable, testable method by which to extend the human lifespan. And also, I should mention that Mars has been in the news. We're talking about going to the red planet. A few months ago, astronaut Scott Kelly came down from outer space. He spent a year in orbit. However, let's be fair about this. If you saw the movie The Martian, you know that it takes more than just a year to get to the red planet. We're talking about perhaps 2 years. 2 years for a round-trip mission to Mars. And the date has been more or less fixed by NASA, of course, plus or minus a decade or so. We're talking about 2030. In 2030, we expect the first astronauts to go to the red planet, and NASA even laid out a 3-part program by which to do this. In Part 1, we would test the booster rocket, the SLS booster rocket, which is being manufactured even as we speak, and we will also test out the landing module called the Orion. The Orion was originally supposed to be part of the replacement for the space shuttle. Sorry about that. The space shuttle was canceled, and Orion was canceled. But we've been able to salvage the Orion space module and put it on top of the SLS booster rocket to give us a Mars rocket. So that's step 1. Test the Mars rocket, the SLS booster rocket, and the Orion space capsule. Step 2. Do something with it. Go into outer space and land on an asteroid. That's right. Asteroids come by the Earth more frequently than is comfortable, and perhaps we'll send the SLS booster rocket with astronauts to land on them to get experience of landing on an asteroid and an extraterrestrial object. other than the moon. For example, some scientists think that asteroids may not be solid at all. Perhaps they're just a clump of loose rocks held together by gravity, and an astronaut walking on the asteroid would find the asteroid falls apart. Well, we don't know. We're going to have to land on an asteroid. That's step 2. Step 3 is actually sending the probe all the way to Mars, either to land on a moon of Mars, Deimos and Phobos are the 2 moons of Mars, or to actually land on the red planet itself. And then, of course, NASA has been experimenting with what it's like to actually live on Mars. If you saw the movie The Martian, you know that it's not comfortable at all. The temperature is below freezing. There's no soil to speak of. It's just basically sand. And there's no oxygen to breathe. The atmosphere is basically made out of carbon dioxide. There's no liquid water to speak of. You can't simply get liquid water from a reservoir or a lake or an ocean. There are no lakes and oceans on Mars. And so you cannot, quote, live off the land. Many people thought that just like the pioneers, they came from Europe to come to this desolate North American continent called America, only to find the fact that, yes, they could live off the land. There was soil that was fertile. They could plant seeds. They could grow crops. They could sell these crops. They could shoot animals for food. And so the pioneers did find out that they could live off the land. They didn't have to bring tremendous amounts of supplies from Europe when they colonized North America. However, on Mars, you cannot do any of the above. There are no crops to be harvested, no animals to be shot, and no air to breathe on Mars. All of that would have to be brought with us when we colonize the red planet.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to throw the lines open because, yes, this is your time to get on Science Fantastic. You have a question? You have a comment? No problem. Give us a call at 866-323-2129. All you have to do is leave your name, the call letters of the radio station, and the city you're calling from. And perhaps you can ask your thoughts, have your thoughts heard on over 100 radio stations that carry Science Fantastic. Okay, moving right along, let's take the first listener phone call.
Hi, Professor. This is Franz from WILK, Nanticoke, Pennsylvania. My question to you is, I've been listening to you for a while, and I don't know if this question's ever been asked, but what science fiction writers, what science fiction comic books or movies have helped you in your, in your striving to come up with string theory and other things? I would be amazed to see maybe Isaac Asimov or Ray Bradbury. But thank you for taking my question.
Okay, well, let me first of all say that string theory, which is what I do for a living, in fact, I'm the co-founder of string field theory, one of the main branches of string theory. String theory, unfortunately, is pure mathematics. So we cannot get inspirations from reading science fiction or clues into the secrets of string theory by reading science fiction or watching science fiction movies. However, I should point out that science fiction has played a pivotal role in the education and the creation of many top scientists. For example, Edwin Hubble was perhaps the most famous of all astronomers of the 20th century. He was the one who discovered the expanding universe, one of the greatest discoveries of all time. And he started out as a country lawyer in Missouri. That's right. His father was a lawyer, and his father wanted his son to be a country lawyer in Missouri as well. But, Edwin Hubble had other dreams. He was a Rhodes Scholar, got accepted to Oxford University, which exposed him to a lot of different kinds of possibilities, came back to Missouri, and he simply couldn't see himself spending the rest of his life doing small cases in a small town in Missouri. He remembered reading Jules Verne as a child. As a child, he thrilled to the stories of going to the moon and going to a comet. So what he did was he earned the ire of his father. He told his dad that, nope, he's going to quit being a lawyer and become an astronomer. He went to Chicago. He got accepted to the University of Chicago, got a Ph.D. in astronomy from the University of Chicago, and went to the Mount Minnesota Observatory and became the man who discovered the expanding universe. Amazing. He was the one who looked at galaxies. By the way, back then in the 1920s, people didn't know what galaxies were. They thought they were simply wisps of gas inside the Milky Way galaxy. He showed that no, these galaxies are island universes just like the Milky Way. Island universes in and of themselves. He calculated the velocity of these galaxies, and he found, much to his shock, that they were moving away from us. All these galaxies, he found, were more or less moving away from us, meaning that the universe is expanding. And so it was science fiction who helped to create one of our great astronomers. Or for that matter, think of Carl Sagan. When Carl Sagan, the great astronomer, when he was a kid, he read John Carter of Mars. John Carter was a fictional person created by Edgar Rice Burroughs, the very same man who created Tarzan. And it turns out that Edgar Rice Burroughs created John Carter, who is a soldier who falls asleep in a cave with gas, and he winds up on the planet Mars. Well, of course, Edgar Rice Burroughs was not a scientist and could not explain how to get to Mars. And so he simply has, in some way, the soul of this soldier being teleported to the red planet. And John Carter meets a beautiful Martian princess, of course. I mean, after all, it is a novel, Dejah Thoris. And Carl Sagan dreamed of chasing Dejah Thoris over the sands of Mars, as he wrote in his autobiography. And so he became an astronomer because of science fiction. Now, when I was a kid, I read about the works of Einstein, and I wanted to help complete Einstein's dream, his unfinished dream of a theory of everything. But on Saturday mornings, I used to watch the cartoons, and on Saturday mornings, what do they have? Flash Gordon with Buster Crabbe. And boy, I was hooked. I mean, spaceships, ray guns, cities in the sky, undersea kingdoms. What's not to love in that series called Flash Gordon? Well, it turns out that yet another dreamer was also watching the Flash Gordon series who was about my age, and that guy was George Lucas. We now know that George Lucas actually went to find who controlled the rights to Flash Gordon. He wanted to create an updated version of Flash Gordon, but unfortunately the rights were not available. So George Lucas gave up the dream of putting his childhood hero, Flash Gordon, on the big screen, and instead made a clone of Flash Gordon called Star Wars. In fact, practically scene by scene, episode by episode, you can see the similarity between Flash Gordon and the Star Wars series.
Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. That's right. This is your chance to get on national radio to ask that question that you've always wanted to ask about science and the big headlines. The number to call is 866-323-2129. All we ask is that you leave your name, the call letters of the radio station, and the city you're calling from. and perhaps your thoughts will be heard on over 100 radio stations that carry science. Fantastic. Okay, well, the lines are open, so let's take the next listener phone call.
Professor, do you think man will ever figure out anti-gravity? Thank you.
Well, it turns out that, of course, anti-gravity is a staple of science fiction, but in science reality, anti-gravity is a lot harder than you realize. In fact, may not even exist at all. First of all, there is something called antimatter. Matter has a counterpart called antimatter. For example, the electron has negative charge, as we learn in school. But there's a positively charged electron called the positron. It is antimatter, and when you combine the electron with the positron, it releases energy. Now, the positron is emitted naturally by radioactive products like sodium-22. In fact, that was one of my science projects when I was in high school. When I was in high school, I actually played with antimatter. I got a Wilson cloud chamber. I got some sodium-22 radioactive source from the Atomic Energy Commission, and was able to photograph tracks of antimatter bending the wrong way in a magnetic field, proving that it was antimatter rather than ordinary matter. Now, if you say that every particle has an antiparticle, well, light is a particle called the photon. So why isn't there an antiphoton? Well, when you look in the physics book, you realize that the antiphoton is the photon. The photon is its own antiparticle. So, sorry about that. There's no such thing as anti-light, which you sometimes see in science fiction novels. Anti-light is basically comes out of a flashlight, except instead of light coming out of a flashlight, darkness. Darkness comes out of a flashlight. Well, sorry about that. It turns out that anti-light is light. And if you take a look at gravitons, that is particles of gravity, the anti-graviton is the graviton. So anti-gravity would be gravity. Now, you may say to yourself, well, this is the cutting edge of physics, after all. So are there loopholes? And yes, there are loopholes. First of all, we have never seen the graviton, let alone the anti-graviton. So it's pure theory. It's pure theory that anti-gravity is the same thing as gravity. But I think most physicists would say that anti-gravity is gravity. Now, we actually want to test this with our atom smashers. If you have a beam of anti-gravity, we want a beam of anti-electrons or anti-protons. We want to ask the question, do they fall up or fall down? Think about this. This is not a trivial question. If I have anti-protons, which we can create, and anti-electrons, which we can also create in an atom smasher, put them in a bottle, and we just wait and see whether they fall up or fall down. Science says they should fall down. However, we've never done that experiment. And so it's an open question as to whether anti-gravity exists or not. Again, most physicists, myself included, would say that anti-gravity does not exist, but no one has done the key experiment allowing anti-gravity to, allowing anti-electrons and anti-protons to fall down rather than fall up. That's one loophole. There's another loophole, and that is in Einstein's equations, there are actually two terms you can put in Einstein's equations. One is the energy of space-time, and that gives us what we call general relativity, the bending of starlight, black holes, the Big Bang, all of it coming from this one term. But there's a second term in Einstein's theory, and that is the energy of the vacuum. Einstein himself thought that this was crucial for cosmology, and we think that it is crucial for something called negative energy. Negative energy, we realize just in the last few years, is perhaps the basic ingredient of the universe. 73% of the universe, we think, is made out of negative energy. Dark matter only makes up 23%. So what about matter, the stars that we are familiar with in the night sky? They make up only 23% of the universe. So in other words, anti-gravity could be in the form of negative energy pushing the galaxies apart. It could be that anti-gravity pushes the galaxies apart. But it's too small to use for a starship. It's too small to use for a hoverboard. So, sorry about that. No anti-gravity in science fiction.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. That's right, the lines are open. It's open mic in this hour. Here is your chance to get on the telephone and have your thoughts heard on over 130 radio stations that carry Science Fantastic. The number to call is 866-323-2129. And all we ask is that you leave your name, the call letters of the radio station, and the city you're calling from, and perhaps you could have your thoughts heard on national radio. And once again, you may want to get a copy of my latest book. It's called The Future of the Mind, now in paperback form. 2 years ago, it hit #1 on the New York Times bestseller list, and it's all about physics. How we physicists are using MRI machines and advanced sensors to probe right into the living brain. What is mental illness? Is telepathy possible? Can we create an Iron Man exoskeleton? Can we do any of the things you see on Harry Potter and Flash Gordon and Star Wars? It turns out the answer is yes, for a lot of the things you see in science fiction. Telekinesis, telepathy, recording memories, sending memories. Yes, we can do all these things now in the laboratory. So find out what it means as we begin to understand the thinking process of the mind itself. The book is called The Future of the Mind. Okay, well, let's move right along and take the next listener phone call.
Hello, Professor. This is Steve. Shouldn't our nuclear plants be switching to thorium as it's safer and it's more plentiful and there's no radioactive waste? Thank you. Goodbye.
Well, you ask an interesting question that a lot of people have asked, and we've had such bad luck with uranium light water reactors that some people are saying, well, let's junk it and start all over again. It turns out that molten salt thorium reactors are superior, as you pointed out. For example, as just one example, the melting point. The melting point for uranium dioxide is on the order of 5,000 degrees, and that's why nuclear power plants will melt fairly rapidly. It only takes about half an hour once you shut off all the safety systems. It only takes about half an hour for a conventional nuclear power plant to hit the melting point and to create havoc in the form of a meltdown. It turns out that thorium reactors have a higher melting point, and it's more difficult to initiate the dreaded Class 9 meltdown. At Fukushima, in Japan, for example, we have not one, not two, but three meltdowns that took place 5 years ago in Fukushima. 5 melted reactors. In fact, the core is so melted it's in liquefied form. But thorium, the nuclear fuel cycle, it's too late. It would cost hundreds of billions of dollars to convert to a thorium nuclear fuel cycle, so it ain't going to happen. Sorry about that. We rushed into uranium, and now we're stuck with it. We're stuck with light water uranium reactors when other designs are actually preferable. So it means that we're stuck with conventional uranium light water reactors.
You're listening to Science Fantastic with Professor Michio Kaku. You're listening to Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. That's right. Here is your chance to get on national radio to ask that question that you've always been wanting to ask. I mean, let's say you're just walking down the street and you're looking at the sky and you're looking at all the wondrous things around you and you wonder, what does it all mean? The sky, the heavens, the trees, what does it all mean? Well, give us a call, and we can talk about what it all means. The number to call is 866-323-2129. Ask a question, and remember, no question is too dumb to put on national radio. Chances are, if you have a question, chances are that same question is bothering other people. And just remember that sometimes the simplest questions are the most profound and the deepest questions of all. When Einstein asked himself a question, can you outrace a light beam? That question was asked by a 16-year-old child. And when he answered it, it changed world history. Okay, well, moving right along, let's take the next listener phone call.
This is Jonathan Williams, Chattanooga, Tennessee. My question regards Fresnel lenses and their applications. I've seen many videos online where Fresnel lenses are used to focus the power of the sun, usually burning wood, et cetera, and so on. My question involves third world applications like desalination of ocean water, et cetera, and so on. Could you please elaborate on some of the uses for Fresnel lenses?
Yes, I'd be glad to. First of all, Fresnel was a famous French physicist who came up with a design for a better lighthouse. A lighthouse has a gigantic piece of glass in the shape of a lens, and he thought, well, what happens if you slice the lens? What happens if you slice it? You would get lots of concentric circles. And what happens if you were to manipulate the shape of each of these slices to increase the efficiency? And sure enough, he showed that mathematically speaking, a solid piece of glass is not the most efficient way to build a lighthouse. And he designed another one. It turns out these lighthouses are superior to ordinary lighthouses because they have a very small focal length but very large aperture size. And that became what is called the Fresnel lens. More recently, people are interested in focusing light for solar power. And yes, indeed, it turns out you can increase the efficiency of a solar panel by using these slices rather than a solid piece of glass. And you mentioned another possibility, well, why not use this for all sorts of industrial applications? Well, then you get into trouble because of the fact that you have to look at efficiency and cost. And then you begin to realize that, well, yeah, you get more efficiency, but in terms of mass producing these things and perhaps helping people in the third world for desalination and stuff like that, it's sort of marginal. And so that's why there's not a big effort to do that, even though you are correct that Fresnel lenses tend to be more efficient than ordinary lenses. For example, take a look at solar power and solar energy. The big problem with solar energy is not so much the efficiency of the solar collection process. The bottleneck, you'll be surprised to learn, is storage. That's right. How do you store the energy of solar when it is dark at night and the sun doesn't shine? Or if you like wind power is great. We see a resurgence of wind power with the building of modern-day megawatt propellers. However, the problem there is, what do you do when the wind doesn't blow? The key is storage, which means a better battery. Now, it turns out that batteries are becoming more efficient, about 7% greater efficiency per year, because finally, entrepreneurs and inventors and engineers are beginning to seriously design better batteries. For example, 100 years ago or so, Thomas Edison and Henry Ford were friends, and they had a bet. What would supply the energy of the future, gasoline or batteries? Edison, of course, bet on the battery. Henry Ford bet on gasoline, and we all know what happened. But ultimately, Edison may have the last laugh, because for 100 years, there were no great inventors and entrepreneurs trying to commercialize better batteries. Now, we see a stampede, because people are saying there could be a gold mine out there. In fact, Elon Musk of SpaceX, PayPal, and Tesla Motors has designed a new type of battery which takes advantage of the fact that the efficiency of batteries is becoming better and better every year. And so we may see a gold rush in that direction. Now, the caller also mentioned desalinization. I speak in the Middle East sometimes, and when you travel through Dubai, for example, or Saudi Arabia, you see all these fountains everywhere. However, you're in the middle of a desert, and you can imagine how expensive it is to create a fountain right in the middle of a desert. In fact, when you go to Dubai, they actually have a ski slope. That's right, you can actually ski on snow in the middle of a desert. That's how energy rich these countries are. So the problem with desalinization is not necessarily the sunlight. The problem with desalinization is energy and cost. It costs a ton of money to begin the process of separating out salt from water to get pure drinkable water. And so the problem there, once again, is not necessarily the sun itself. The problem is reducing the cost and the energy requirements. It costs a lot of energy to begin the process of separating out salt from ordinary salt water to extract drinkable water. And you also have to be careful about this. Australia invested billions in a series of desalinization plants because they had a drought. But after they built the plants, what happened? The drought ended after 7 years. And so they had an oversupply in desalinated energy. Okay, well, we've run out of time. So that's it for Science Fantastic with Professor Michio Kaku.